Hello. Sentences in predicate logic can contain more than one quantifier. And when we have more than one quantifier, these occurrences are nested inside one another, and changing their order can produce differences in meaning. Here's what I mean. So we have these two sentences, and here we have two universal quantifiers in a row. And we also have an interpretation. I'm omitting three sentences here, which would be LAA, LBB, and LCC, but it's just for the purposes of illustration to make things tidier. Okay. Now, both sentences mean the same. It's everybody loves everybody. Here we have a universal quantifier binding into the lover position, and also a universal quantifier binding into the beloved position. So it doesn't matter really the order. They're both going to say the same. You can see that they're both true in the same circumstances. They say that everybody loves everybody. So let's see whether they are true or false in this interpretation. So we start scanning from left to right, and we find that, well, Beth doesn't love Al because the sentence LBA is false in this interpretation. Therefore, both sentences are false. And if we change interpretation, we would also see that perhaps both of them would come out true. Depending on the interpretation, the fact is they're always going to have the same truth value because they say the same. So changing the order of these two universal quantifiers is not going to change anything. And the same is if we had also two existential quantifiers in a row. But what happens when we have two kinds of quantifier? Here we have a universal quantifier, here we have an existential quantifier. This would say, for instance, if L is love, again, it says that everybody loves someone. Or for every X, there is a Y such that X loves Y. Now let's do an experiment. Let's just swap the order of the quantifiers. And again, the quantifiers are binding the same variables. We have the universal binding into the lover position, and we have the existential binding into the loved position. The only change is that we swapped the order of the variables. So remember that the first one said everybody loves somebody, but the other sentence, number 4, means something different. It means somebody is loved by everyone, because it means there is a Y such that for every X, X loves Y. And we see that they mean something different, right? It means the first one means that everybody loves somebody or other. And the second one says that there is a special someone, right, that is loved by everyone in the domain. And so, is 3 true then in this interpretation? Well, we see that Al loves Beth, we see that Beth loves Claire, and we see that Claire loves Al. So clearly, everybody loves somebody or other. So we see that 3 is true. But what about 4? Well, if we start scanning from left to right, we see that Al isn't loved by everyone since Beth doesn't love him. Also, Beth isn't loved by Claire, and Claire isn't loved by Al. So for every person, there's at least one person that doesn't love them. So it is not true that there is somebody that is loved by everyone. So you see that 3 is true and 4 is false. So they're not true in exactly the same situations. So as far as PL is concerned, they don't mean the same. And in fact, in English, they represent 2 different meanings. So you have to watch out for the order of the quantifiers. Now, let's revisit our definition of binding. Remember that the scope of a quantifier is the shortest false sentence that immediately follows it. So everything within that sentence falls within the scope of a quantifier. And again, our definition of binding so far is that an occurrence of a variable u is bound just in case it occurs in the scope of a quantifier, whether universal or existential. And correspondingly, an occurrence of a variable u is free just in case it is not bound. So to illustrate this, suppose that we have this sentence. And notice the structure of this sentence. Notice the main connective. The main connective is the V. So this is actually, in essence, a disjunction whose left disjunct is an existentially quantified sentence and whose right disjunct is fx. So the first occurrence of x is bound by definition because the occurrence of the variable that is next to the quantifier is automatically bound. The second occurrence of x is also bound by the quantifier because, well, it is the same letter and it's also within the scope of the quantifier. What about the third occurrence of x? Well, it is also within the scope of x because the scope of x, again, is everything that is to the left of the v. Well, that variable is also bound by x and is the same letter, so it's bound. Now, y, even though it is within the scope of the existential quantifier, is not bound because it has a different letter. And x, although it is the right letter, it has the same letter as the quantifier, it occurs outside of the quantifier scope because, again, the v forms a sort of barrier to the scope of the quantifier. So far, this definition gives the right answers as to which variables or as to which occurrences of variables are bound or free. But we have a problem, which will lead us to modify our definition. So this is not going to be in the exam. So if you want, you can skip this section and skip it to where it says new definition of binding. On the other hand, if you're interested in knowing why we're going to modify the definition, then you're welcome to follow. So the problem is that having the same letter as a quantifier and being in the scope of that quantifier are not jointly sufficient for an occurrence of a variable u to be bound by that quantifier. Consider this sentence and focus on the third occurrence of x, which here is in red to make it more salient. So is x in red bound by both quantifiers, neither quantifier, only the existential, or only the universal? The correct answer is for only the universal. Even though red x is in the scope of the existential, and even though the letter x occurs with the existential, x is not bound by the existential. And the reason for this, well, there are two reasons for this. One is a principle, and the other one is, well, the way in which 5 is put together. The principle is that in predicate logic, an occurrence of a variable cannot be bound by more than one quantifier at the same time. So a given quantifier can bind more than one variable. But the reverse is not true. A variable cannot be bound by more than one quantifier. So this sort of promiscuity is permitted of quantifiers, but not of variables. I know that there is a double standard here and that is unfair, but let's move on. So now let's put it to the other side. Let's illustrate how the sentence is put together. Again, something that you have to bear in mind is that the sentence that is within the scope of the existential is conditional in form. So the antecedent is this universal sentence for every x LXA, and the consequent is LXB. So let's see how we construct this sentence. In the right bottom corner, I'm writing the target sentence, so as to keep in mind what we're building up to. So we begin with these two free sentences, LXA and LXB, and again, the occurrence of x that we're tracking here is in red. So our first step is to prefix this sentence with a quantifier. And we see that immediately this occurrence of the variable is bound by the quantifier, so it's locked in. No other quantifier can bind that occurrence of a variable. Okay, so the result is sentence 6. And now what we do with this other variable? Well, we see where it occurs. It is the consequent of the conditional. So we make a conditional with these two. And so the universal is going to be the antecedent and LXB is going to be the consequent. And notice that at this point, x in red is bound by the universal quantifier, but the last occurrence of x is still free because it's not within the scope of the universal. Okay, so we write 7, is our intermediate step. If there is an x LXA, then LXB. Okay, so at this point, there's only one variable occurrence that is available for binding, which is the last occurrence of x, because that's a free occurrence of x. Okay, then our last step is going to be to add the existential quantifier in front of the whole sentence. So we add it. Well, we know that these red occurrences of x are already taken because they're bound by the universal. So the only one that is left is the third occurrence, the last occurrence of x, So it's going to be bound. And that is the final situation as regards to binding. So we'll reach our target sentence. Now, of course, all of this confusion would have been avoided if we had assigned a different variable with each quantifier that we introduce. So if we associate x with the universal quantifier and y with the existential, then there is no mistake as to which quantifier binds which variable. So from this, we can draw two lessons. The first one is quite practical. When two or more quantifiers overlap in scope, you should use a different variable for each of them, so as to avoid confusion. So instead of writing this, you should write this. The other one has more theoretical importance, which is that we need an amendment of our previous definition of binding. So in addition to our scope requirement and to our same letter requirement, we need a freedom requirement. So this is how our new definition is going to go. A quantifier QU, where Q can stand for either the universal or the existential, well, this quantifier binds an occurrence of variable u if and only if u is in the scope of QU and u is free. So that is, a quantifier can only bind an occurrence of a variable if such occurrence is free in the sentence to which the quantifier is attaching. So if we want to attach the quantifier on the left to the sentence to the right, so there's only one variable that is available for binding because the only one that is free in that configuration. The first one can't be bound because it's already taken. It is already bound by the universal. Okay, this means that we also have to amend our definition of substitution instance. So here it goes. For any quantified sentence, u, and notice that the first set of parentheses encloses the quantifier variable sequence, and the second set of parentheses flanks the sentence that is in its scope. Well, for any such quantified sentence, the substitution instance of the sentence with the name s substituted for the variable u is, well, this, which is basically the sentence formed by dropping the initial quantifier and writing s for all free occurrences of u in the sentence in the scope. And here the key difference from our previous definition is that we don't just drop the quantifier and then indiscriminately write the name wherever the quantifier's variable had occurred within the scope. Rather, we can only substitute those occurrences that become free when we remove the quantifier. An example, sentence x is a substitution instance, c for x, of 10. And so, how do we get that? Well, we have c there, and then where can we rewrite it? Well, imagine that we remove the first quantifier. Well, even when we do that, we notice that the first three occurrences of x are taken. They're already bound by the existential. But the ones that are still free are the fourth and fifth occurrence. And so we're going to substitute all of those, the ones that were within the scope of the widest quantifier that we're substituting, by c. So we substitute c here, and we substitute c here, and we are done. Another notion that needs to be modified is truth in an interpretation. And again, we need to talk about open versus closed sentences. And remember that a sentence S is an open sentence if and only if S contains one or more free variables. And a sentence S is a closed sentence if and only if it is not open. Now, remember, and this is very important, the notion of truth in an interpretation only applies to closed sentences. That is, those with no free variables. An open sentence can be neither true nor false in an interpretation, in the way in which we have defined it. To see why, notice that variables in predicate logic are often compared to pronouns in natural language, like it, she, or he, at least on certain uses of pronouns. So if I wrote an open sentence like fx, it is as if I uttered the English sentence, it flies, but I'm not pointing to anything, and there's nothing in the context that indicates what I'm talking about. So you're not going to know if it's true or false until I point to an object or replace the pronoun with a name that we're both familiar with. Now, there is a technique of assigning values to variables that is somewhat analogous to pointing to objects, but we won't be studying it here. For now, what I want you to remember is that if a sentence has at least one free variable, it can't have a truth value. It is neither true nor false. Okay, here's our amended definition. A universally quantified closed sentence S is true in an interpretation I if and only if all of S's substitution instances, formed with names in I, are true in I. Likewise, an existentially quantified closed sentence S is true in an interpretation I if and only if some of S's substitution instances, formed with names in I, are true in I. So it's the same, but we are replacing all with some. Okay, that's all for this lesson. Bye.